Hi guys, now we are in K.7, which is going to be geometric proofs, okay? So we're still playing with our 4 favorite shortcuts. You know them forwards and backwards. Now we're going to be seeing them in proofs. So remember, proofs are a flow of reasoning. So on the left-hand side are what steps are taken, and the right-hand side are the reasons that those steps are taken. So what you should expect on the very last step, it should always be one of our 4 shortcuts, okay? So let's go ahead and just throw off CPCTC. That's not coming yet. That will. And the definition of congruence, that means when you go from an equal sign to a congruent symbol. So that's not going to be happening here. So basically, guys, it's going to be one of the 4 shortcuts. So what you need to do is look at what they are giving you. So VW is perpendicular to UX, given, okay, right angle. Angle W is given, congruent to angle V, given. And then UX is congruent to UX reflexively. So how are these triangles congruent? Side, angle, angle, side, angle, angle. So this is another one. So let me say side, angle, angle, or in their case, angle, angle, side. So this is another IXL where I would turn on your Zoom and record yourself so that you have the ability to annotate so you can write on the screen. You can also do that, or you can draw these in your notes because you know it always helps to write things down. Okay, so your whole goal is to just see how are these triangles congruent. So it's not going to be CPCTC, your definition of congruence. Okay, now what do we know what's going on? Okay, we know angles are congruent. All this is marked up. And then they start doing the additive property of length. So they're saying FJ is congruent to these two guys. And then GI is congruent to this and this. Okay, so let me just erase all that mess because that got real sloppy. So where they're going with that is then they substituted and said, FJ is equal to FG plus FI because these two pieces are the same. And what they're getting at and what's important for us is GI equals FJ. So this leg here equals this leg here so that you've got congruent sides going on. So that's what that whole mess was. Okay, so I got really messy. I'm sorry. So what we've got going on is angle, side, angle. Angle, side, angle. So this would be ASA. I gave you a long-winded explanation. What you're really just trying to see is how these triangles are congruent. Okay, this one, they're mean. They didn't mark anything up. This box, I moved up top so we can see it. So we've got to mark a lot of things. Okay, UWY is congruent to UXW. Okay, given. I'm going to check it off once I mark it. XUY is congruent to XUW. XUY is congruent to VUW. Okay. UW is congruent to UX. UW is congruent to UX. This is just so much to mark up. This is why you want to be marking up your pictures. Okay, so they're doing additive property of length. That's nothing you need to add to your picture. What we need to add to our picture is this part. So VUX, where's V? VUX equals WUY. WUY. Okay. So then how would we know UVX, triangle UVX, UVX, how would we know this big triangle here is, now I'll do that one purple, I did that one in purple, is congruent to, let's pick a new color, let's go ahead and pick green, UYW, UYW. So how do we know these triangles are congruent? So what do we got going on? Okay, so let me see. It looks like I've got an angle, a side, and an angle. And the same thing's happening on this side. Angle, this side, and then this angle here. So this would be an ASA. Oh my gosh, I'm such a blonde. I did the very, very bottom one. So let's see. Sorry, I got excited and just went to the very end. They didn't even want that one. Ugh. Well, at least I know I'm right. It's ASA. What did they do? Okay, here's the thing. When they do additive property of angle or length, okay, typically the third step, this one here, what we're looking for, that's typically going to be a substitution. And here's why. Here's what to look for. Sorry, guys, I was finding the wrong thing. Okay, so what happened? They kept WUY, okay, and then they kept WUX, so that remained consistent. What happened is they took out XUY and somehow put VUW in there. Where would that be allowed from? They did that here. They put VUW into here. That is a substitution. Okay, so anytime you see additive property twice, the next move is going to be a substitution. I believe it happened up here. Yeah, additive property, and then a substitution. Well, that could have been so much easier. Okay, let's get to the next one. Let me not get too much into it. You know, even just looking at this, guys, I don't even need to mark up the picture. I'm reading this proof, given. Now, what's the very next thing? TX, this whole segment here is made up of TU and UX. So it's made up of two pieces. Well, that's an additive property. Additive property of length. Okay, so I didn't jump for it, and I didn't have to go and find out it was side. I just find that missing piece. I'm so used to writing proofs all on my own. Okay, let's see. So this box here, this upper box, I'm just getting my color here. This one goes to here, and this bottom one goes to here. Okay, so let's see. What do we got here? Triangle VXW is congruent to WYX. Now, here's the first time we see CPCTC, so let's talk about it. CPCTC stands for corresponding parts of congruent triangles are congruent. Okay, so what does that mean? That is a mouthful. Yes, it's CPCTC. It's a very common term. What that means is when you have two triangles congruent to each other, so are their parts. So, for example, VXY is congruent to WYX. So what that means is those two triangles are congruent, so are their parts. So that would mean angle V is congruent to angle W. So this guy is congruent to this guy. Angle Y is congruent to angle X. Oops, I better put two arcs there. The side lengths are congruent to each other. So that's where corresponding parts of congruent triangles are congruent. So that's where that comes from. So what's happening is they give me two triangles congruent, so then I'm allowed to say, well, so are their parts. That's why they're then saying VY is congruent to WX, which I went ahead and marked. So then how would we know VX is congruent to WY? Well, again, that's CPCTC. If triangles are congruent, so are their parts. And then they're saying, well, VW is congruent to VW by reflexive property. So how do we know these two triangles are congruent? Well, here's a big takeaway. We've only brought up sides. So this would be a side. Okay, you're going to see a lot more CPCTC in the next coming IXLs. So we'll talk about that more then too. Okay, so let's see. What do we got going on? All right. They're giving us two triangles are congruent, and then they're using CPCTC to say so are the parts. Now look, anytime you've got an additive property of length twice, the next thing's substitution, but make sure it is. So UX is coming here. VW got swapped out with UV where? Here. And then VX got swapped out with VY. VX and VY got swapped out here. So that's definitely substitution. Like a double substitution, but no need to say that. Okay, so then how do we know XY is congruent to XY? Well, that's reflexive. So then now how do we know the triangles are congruent? Which of the four shortcuts? Okay, so when triangles are congruent, it's never CPCTC. Well, let's see what's marked up here. So UXY is congruent. Okay, so XY is congruent to itself, obviously. Okay. UX is congruent to WY. And then, let me see, VY. Oh, VY doesn't help us any. UY, UX. Oh, here we go. WX is congruent to UY. So the only thing we've talked about is a side, side, and side. Side, side here, and then this side here. So this would be a side, side, side congruence. I could have seen that in this whole proof here because we didn't talk about angles at all. The only thing talked about was sides. So that's a giveaway too. All right, let's go ahead and knock out K8, which is more proofs. Okay, so complete the proof here. So guys, here's where CPCTC is going to be used a whole lot more. Now, when triangles are congruent, so are their parts. So what you're going to see now is the second to last step is going to be one of our 4 postulates that we've been using. And then the last step is going to be CPCTC. So you can count on the second to last step to be one of these 4, and then it's going to end in CPCTC. So let's go ahead and see what's given and marked. So TW is congruent to UX. Angle W is congruent to angle U. That was marked. And then angle S is congruent to angle S. Well, obviously, because it's shared. So how do we have, it also helps to sometimes draw off the picture. So SXU. And then I'm drawing this one over here. WST. So you could actually mark it here. So TW is congruent to UX. So I'm actually going through it all again. Angle W is congruent to angle U. And angle S is congruent to itself, angle S. So how do we know these are congruent? It's going angle, angle, side. So it would be AAS. Angle, angle, side. Okay. Ooh, here's a big one. Let me see here. So VWY is congruent to XUY. So VWY, so they're already telling me these triangles are congruent to each other, is congruent to XUY. So VWY, XUY. Okay, you got vertical angles here, and then your third side here. Okay. So then how would I know? So UY is congruent to WY by CPCTC. And then how do I know VY is congruent to XY? Another CPCTC. We're done. Okay, we saw something like this very similar in our couple lessons ago in section K. So let's see. Now they're just giving you a lot more options. These 2 boxes go up above. Okay, so some giveaways. Additive property length is typically going to happen twice. So this is going to be another additive property of length. Okay, and then what they're always going to do next is they're going to take these 2 equations and somehow merge them using a substitution. So like SW is staying, VW got swapped out for ST. How? Here, because they're congruent. And then SV stayed. Okay, so that was just a single substitution. So I always say, I know it's a substitution, but I do always check. That's really important. And then now they went ahead and they're saying, hey, so triangles are congruent using side, side, side. Now remember, if this is the second to last step, the last step is going to be if triangles are congruent, so are their parts, which would always be CPCTC. So now we're starting to get the flow of a proof and what they're always doing within it. Okay, now this is just a fun one because the whole thing's blank. Let's get through it. Okay, S is the midpoint of QR. So first of all, given, What I'm also going to do is mark it up, guys. If S is the midpoint of QR, that means these two pieces must be congruent because the midpoint, by definition, cuts it in half. So now they're saying QR is perpendicular to PS, okay? It wasn't written up here, but it is given because it's on the picture, okay? And if you've got a right angle on the left, you're going to have a right angle on the right. So then our next step is PSQ is congruent to PSR. So they're saying these right angles are congruent. Well, of course they are. That's going to be the definition of right angles. Is that what they call it here? Oh, all right angles are congruent, okay? So if you've got a right angle on the left, you're going to have it on the right. So all right angles are congruent. And then how do we know QS is congruent to RS? Well, I look up, I marked it. How did I know that? Well, that came from the word midpoint. So that's going to be a definition of midpoint here. Definition of midpoint. And then how do I know PS is congruent to itself? Well, that's a reflexive property. And is it congruence or equality? Well, it's going to be congruence because they're using a congruent symbol. Okay, so that's obvious. So then how do I know these triangles are congruent? Well, they're going side, angle, side. So that's a SAS. If triangles are congruent, so are their parts. C, P, C, T, C. Okay, so there's one more. And I suggest maybe pausing it, trying it on your own, push play to check it. This is our last one together, okay? All right. So FI bisects angle GIK. Given. I'm going to mark it up. FI bisects GIK. Okay, so those guys are congruent. That's why you got to draw on the picture. So if you don't use the annotate button on your computer, draw it on your notebook. Otherwise, this would be impossible. FI bisects HFJ. HFJ. Okay, so these guys are congruent. Okay, also a given. They're given up top. Now I need to prove that parts are congruent. So guys, to be perfectly honest, I know this very last bit is going to be CPCTC. I'm looking through this proof here. What I see here is additive property of length. That's happening twice. So I'm going to say ditto. These are marks meaning ditto, which means same thing. Long before computers, when copies were made, they were called dittos. They were just repeats. So then usually the next step is going to be a substitution. Let's just make sure it is. Track everything. So FIJ stayed. FIG must have gotten replaced here because they are equal to each other. And then GIH must have gotten replaced with JIK. GIH and JIK, which they're replaced up there. So that is a substitution. A double substitution, nonetheless substitution. Oh my gosh, what just happened? And I think I spelled substitution wrong. Good thing I'm a math teacher, not an English teacher, right? Spelling's important. Okay, now back up to up here up top. I like to fill in what I know for sure. So then, okay, so how do we know JIK? JIK is congruent to GIH. So how would I know that these guys are congruent? Oh my gosh, they're my favorites. They're vertical angles. Vertical angle theorem, which is right here. Okay, now how do I know FIK is congruent? So FIK is congruent to FIG. Well, I made that marking because of an angle bisector. So where would I see that? Oh, that would be definition of angle bisector. So you're just defending the steps. That's where this is coming from. Now, how do I know IFJ is congruent? How do I know this angle here is congruent to this angle? That's another definition of angle bisector. So I'm using ditto again, okay? Okay, the rest of my steps are good. Now let's go down. How do I know angle FIH is congruent to FIJ? Let me see. FIH is congruent to FIJ. FIH, where would that have come from? I'm looking up above. I'm trying to see up above where FIH and FIJ are written in these statements here. Kind of want to clear some, I'm going to erase there. So FIJ, or excuse me, FIH is here. FIJ is here. Oh, this is fun. So somehow we're setting, ooh, this is good. Okay, we're going to use this as FIJ. So we are somehow setting these two guys equal to each other. And we can do that because these two are equal to each other. That is, so what we're doing, guys, is we're merging two equations. A merge is called a transitive property. That is a big transitive move to make those equal to each other. Transitive property, that's when you merge two equations. These guys looked the exact same, so we're just going to merge them out and set these two equal to each other, which is down here, or congruent to each other. And then how do I know Fi is congruent to Fi? Well, that's reflexive property of congruence. Okay, and now how do I know Fij is congruent to FIH? Well, look at my markings. Let me change into a different color. So it's going angle, side, angle. So it would be an ASA. Whew. Thank you for sticking with me on this one. I would say these are the toughy ones, but you did great, I'm sure. And of course, email your teacher with any questions.